Okay, so in this video, we're going to be looking at the isotope review guide for your test that's on either Thursday or Friday, depending on what group you're in, A or B. So it's all kind of that math stuff that we've been looking at using that formula where you multiply the mass times the percent abundance and divide it by 100. So this first question, all right, it's in like a little paragraph form, but it's the same thing you've been seeing. It says a sample of iodine atoms was analyzed and was determined that 80% of the atoms had a mass of 127. It was also determined that 17% had a mass of 126. The remaining 3% had a mass of 128. Calculate the average atomic mass for this sample of iodine. Please show all work. So the work part is the actual math. The nice thing is I mentioned 3 isotopes, right? 127, 126, and 128. All I have to do is multiply those by their abundancy. So the first one was 127 times 80. Now I'm going to add that to my second one, which was 126 times 17. I had one more, and that one was my 128 times 3. All right, then all of this gets divided by 100. I can't really type out over 100, so I'm just going to type it out like this, but you're just dividing the sum of these 3 things by 100. If you type that into a calculator, you should get 126.86. If you want to check your answer, go to the periodic table and find iodine, and you'll see that it has a mass of 126.9. This is very, very close to 126.9, so I know that my answer is correct. Question number 2, same thing, just only 2 isotopes instead of 3. Rubidium has 2 common isotopes. Rubidium 85, remember in nuclear notation the mass is the top number, and rubidium 87. The abundance of 85 is 72.2, so that's going to be my first parenthesis. I'm going to do 85 times 72.2. The abundance of rubidium 87 is 27.8, so that is my second parenthesis. What is the average atomic mass? So I only have 2 isotopes. This one's a little bit easier. I just have to find the sum of these 2 and divide it by 100. And if you type that all into a calculator, and I would recommend pausing the video if you haven't done this yet and maybe trying it out, then checking your answer. That's kind of the best way you're going to learn it. But if you type it into your calculator, you should get 85.6. A couple ways you can kind of see if your answer was correct is 1, go look at the periodic table and find rubidium. You'll see that the atomic mass is pretty close to this number. The other thing you can do is, my 2 masses were 85 and 87. 85 is way more abundant, so we would expect our answer to be closer to 85, which is exactly what it was. So 2 ways you can kind of gauge if you're in the right spot there. But 85.6 should be your answer. If you round it a little differently, not a big deal. 3, nitrogen has 2 naturally occurring isotopes, nitrogen 14 and 15. Using your periodic table, determine which isotope is the most abundant and explain how you can tell. So you can Google a picture of the periodic table, you can use your actual periodic table, you will have one on your test. You'll see that the mass listed there is about 14, so I know that nitrogen 14 is the most abundant. Oh, I cannot spell. All right, and because, and it's exactly what you did, you looked at the periodic table. So because that's the mass listed on the periodic table. Number 4, chlorine has 2 naturally occurring isotopes, chlorine 35 and chlorine 37. Using your periodic table, determine which isotope is the most abundant. Same thing we did in number 3. We just have to find chlorine on the periodic table and see which one the weight is closest to. If it's closer to 35, I know this is the most abundant isotope. If it's closer to 37, I know that this is the most abundant isotope. If you go ahead and look at a periodic table, you'll see that chlorine 35 is the most abundant. 5, refer to the periodic table, write the mass number for the most common isotope of sodium. So we're just looking for, okay, what is the weight closest to on the periodic table? The weight on the periodic table for sodium says 22.9. We would round that up to 23. 6 wants a hyphen notation for what is the most common isotope for lithium. All right, so hyphen notation, that means I have the name of my element, hyphen its mass. So I need to go to the periodic table and find the mass that's listed because that's my most common isotope, my most abundant isotope. I'll notice that it is like 6.9 something, so I'm going to write 7. Lithium-7 is my most abundant isotope. All right, 7 wants the nuclear notation. I can't really type the nuclear notation, so I will just describe it here. But nuclear notation, I know I'm going to use the symbol for silicon, which is Si. I gave it to you right here. Most common isotope, again, go to the periodic table, see, okay, what's the atomic number, what's the mass. For the mass, you should see that it's closest to 28, so 28 should be on top. It's atomic number 14, so 14 should be on the bottom. Same with 8, nuclear notation, for the isotope that has an atomic number of 21 and a mass of 46. If you go find atomic number 21, it is scandium, which is Sc. Then I just have to take these two numbers, put 46 on top and 21 on bottom. How many neutrons does it have? Remember, my number of neutrons I can figure out by doing the mass minus the atomic number, because this is also the number of protons that I have. So 46 minus 21, you get 25. So that is my number of neutrons. All right, 9, write the hyphen notation for the isotope that has 15 protons and a mass of 32. So 15 protons means I'm looking for atomic number 15, which is phosphorus. And then I don't even have to look at the mass on the periodic table because it already gave me the mass. So I just have to say hyphen 32. And then same thing we did up here. How many neutrons does it have? I'm going to take the mass and subtract the number of protons, and you get 17. All right, our next question, we have one of these charts, which I know you all love so much. I'm not going to fill out the whole chart because if you can do 1 or 2 of them, you can probably do the rest just fine. But if you really want me to go over the other ones, I probably will do it in class, so you always have that. I'm going to start with this first one up here. I'm probably going to skip nuclear notation again, just because I can't really type it. But so I have 2 things right here. It tells me phosphorus and a mass of 32. All right, so knowing that this is phosphorus, right there I can figure out pretty much all this information. If you find phosphorus on the periodic table, you're going to see its atomic number 15. So I'm going to come over here, say, okay, I know it's atomic number 15. If I know the atomic number, that means I also know the number of protons and the number of electrons. So I can put 15 in for these 2 as well. These 3 boxes, protons, electrons, and atomic number, should always be the same number. All right, then this one, number of neutrons. That's where I take the mass and subtract my number of protons, my atomic number, right? They're all the same. So 32 minus 15 gives me 17. And that's it for that row. Your nuclear notation, I would take the element symbol, which is a capital P, put the weight on top, which is 32, and the atomic number on bottom, which is 15. Don't get confused. Because I gave you the mass right here, right? It's an isotope. You don't want to put the mass that's on the periodic table right here. You want to use the mass of the isotope. That's just something to look out for. That's where I see a lot of people goof up on their test, is they don't take the mass of the isotope. They go and they find a different mass from the periodic table. All right, the second row. This time I did not give you the hyphen notation, but I did tell you the number of protons and neutrons, so we can still figure everything out. If I know the number of protons, that means I know my number of electrons, and I know my atomic number. All right, then I get over here to the mass. Well, the mass is the sum of my protons and my neutrons, so if I add together 41 and 53, I'll get a mass of 94. Then the last part, I just have those notations. I know I have atomic number 41, so if you go to the periodic table and you find 41, you'll see niobium. Hyphen notation, I have to put its mass in there. Again, do not just pull the mass straight off the periodic table. Use the mass you calculated over here. So I'm going to say niobium 94. I will just do one more for you. The third row gave you 2 things, the mass and the atomic number. All right, so if I know the atomic number, I know my electrons, I know my number of protons, I know the mass and my number of protons. So if I subtract 12 from 27, you see that I get 15, so I have 15 neutrons. Then for my hyphen notation, I have to look for atomic number 12, which is magnesium. hyphen, and then the mass I have for over here is 27. Hopefully, if you could do those three, the other three are just the same, but again, I will post the key on Classroom, so you'll have that to look at. All right, last couple questions. 11, compare the nuclear notations of the following 6 mystery elements below. Put the element symbol on the blank line and circle the ones that are isotopes of the same element. All right, so nuclear notation. My mass is the top number. My atomic number is the bottom number. So that's going to make it really easy for us to tell which 3 are the same element. But we'll just start up here. I'm looking for what is atomic number 23. You should get vanadium, which is a V. Down here, I'm looking for atomic number 8, which is oxygen. So I have an O. All right, up here, I'm also looking for atomic number 8, which is still oxygen. Down here, I'm looking for atomic number 22, which is titanium. Up here, I'm looking for atomic number 24, which is chromium. And then the last one, again, atomic number 8, so I'm looking for oxygen. The last part, and I can't circle on here, but I'll maybe try and highlight it, circle the ones that are isotopes of the same element. You're looking for which ones have the same atomic number. That happened to be these 3 for us, right? They're all oxygen, so these would be the 3 I'd want to circle. These have different atomic numbers, therefore they are different elements, so they cannot be isotopes of the same element. You will have a question just like this on your test, so be ready for that. 12 is hopefully a pretty easy one for you, review from the last unit. What 2 subatomic particles contribute to the mass of an atom? So what 2 things do I add together to get the mass? Hopefully you know that's my protons and my neutrons. And then where do I find my protons and my neutrons? In the nucleus. The only thing that I don't find in the nucleus is my electrons, and they have nothing to do with the mass. So we only really need to focus on protons and neutrons for the sake of this test. And then 13, why do isotopes have different mass numbers? So if you remember the thing we've kind of been saying over and over again throughout the unit, why do they have a different mass? Well, it's not because they have a different number of protons. If they had a different number of protons, I'd have different elements. So isotopes have different mass numbers because they have different amounts of neutrons. You could say they have a different number of neutrons, some have more neutrons, some have less, that's all fine. The key thing is they have different amounts of neutrons. That's what makes them isotopes, that's what gives them a different mass. And that is the end of the review guide for your isotope unit.